forget to like and subscribe. So here we have a probability type of practice question. So it says a family photograph needs to be taken for a family of 5, inclusive of mother and father. So in total, there are 5 and there are 3 children. All right, there are 3 males and 2 females. In those 3 males, they're including the parents. It means that there is father and 2 males, and then there are 2 females. It means there is 1 daughter and the mother in the family. So they need to sit in a row. And then the first question is, in how many different ways or how many ways can 3 males and 2 males sit in a row? They have to sit in a row. So which means let's make our row. We're going to make 5 spaces over there. So you're going to ask yourself, the first space will be occupied by 1 person out of how many people? Out of 5 people. So okay, they can either be the mother sitting there, they can either be the father sitting there, they can either be, so any of those 5 people can sit over there. I hope that is very clear to you now. So now the second space will be occupied by 1 person out of how many people? Out of 4 people. Maybe let's say here it was the mother, let's say here it was the father, for example, now, and then we're left with the children now. Let's say the daughter sits here. So it's 1 person out of 3, out of 2 sons and 1 daughter, and 1 daughter. In total, there are 3. So which means 1 person out of 3 was able to sit there. So now we are left with 2 sons. Here, they can either be Johannes, maybe, or Moses can sit there. So which means there are 2 choices. You see, 1 person out of 2 can sit over there. And then now the last one, just one. So that is actually 5 factorial, of which this is simplified factorial in other way, or in other words, of which that is 120 ways of doing this. And then in how many ways can they sit in a row if the father and the mother must sit together? Now the mother and the father, they must sit together. So we're going to open our spaces over there, but we make a group for the mother and the father. So now what happens is you are going to see that when you make your spaces or your slots now, when you count, you're going to have 1, 2, 3, 4. That's 4. So what I mostly prefer is that this one, I'm going to leave it like this. I'm going to open another one for the 4 of them. All right. So I'm going to ask myself here on this one, how many people can occupy the, and this one is our unit. We count them as 1 person. They are sitting together. How many people can occupy there? They can be 1 out of 4 of them because we have 1, 2, 3, 4. That one is our unit. We count it as 1. Then the second space will be occupied by 1 person out of how many people? Out of 3 that are left. And then 2 and then 1. Now, what about those ones that are unit? Listen carefully. The father can either sit here and the mother can over sit there. But the mother can either also sit here and the father sits there. So there is also arrangement occurring in our unit. So which means the first space can be occupied by 1 person out of 2. It can be either the father or the mother. And then here, if here it's the father, then obviously 1 person will be left to occupy that one. So which means I simply close this and open another factorial. uh, yes, and do another factorial by simply multiplying there and say 2 times 1. The reason why we do it like this, it's because this unit can either occupy the first space or can occupy that space or can occupy that space or this one. I hope that makes a bit sense to you. Or in terms of the factorial, you can say 4 factorial multiplied by 2 factorial. And then this will give you 48 ways in which they can sit over there. Now, let's go to the third question. which is in how many different ways can they sit in a row if males and females are to sit together, each to sit together. Yes, so I'm going to open 1, 2, 3, 4, 5, but I'm going to make groups now. That's the group of There's the group of female, and this is the group of male. But what happens is, I want you to listen attentively. It can either be, okay, I said this is the group of males or the group of females, but it can also be in this way. This is the group of female, and this is the group of males. But in simple terms, I'm saying that the arrangement can start by males or can start by females, which means I already have two ways. I can start by this, I can start by this. I already have two ways in which I can put this, okay? This is way number one, way number two. That's fine. Now, the thing that I'm going to do is I'm going to get into my, okay, that two is alone over there. That two, you leave it like that. Then I'm going to get into the arrangement now. The first space for the male, the first space can be occupied by either the father or one of the sons. So it can be one person out of three. And then if the father occupies there, we're left with two sons. One of them can occupy this, and then the last one occupy that one. So we multiply there. And then over here, for the females, the mother can take this space or the daughter. So it's one out of two. And then right there, we have one. Okay. Same applies to this part. 3, 2, 1 over there, over there. I hope we are fine. So in simple, I can say 3 factorial over here because it's 3, 2, 1, and then multiply by 2 factorial over there. So my answer, the overall answer that I get is simply 24 ways of the arrangement over there. So now they said in how many ways can they sit in a row if the females are to sit together? Well, making the females to sit together. In this case, females must sit together. So for the females to sit together, we're going to open our spaces again. This part of probability is very simple. You just have to be strategic in what you're doing. Okay, the females are to sit together. How many females? We have two females. So which means I count this as a unit. I have 1, 2, 3, and then 4 over there. I open 1, 2, 3, 4. All right. Now, the first space can be occupied by one person out of how many? Out of 4. I'm talking about this. The unit, I'll count it as one person. And then if one person occupies there, how many can occupy here? 3. And then if one occupies there, how many now? 2. And then lastly, 1. But because we have a unit, inside the unit, the mother can start first and the daughter, or the daughter can start first, then the mother in terms of the arrangement, which means I also multiply over there by 2 times 1. Because if inside the unit, if the mother decides to start, okay, inside the unit, I'm going to say it's either the mother or the daughter. The first space will be occupied by one person out of how many people? Out of 2, the mother and the daughter. So it's 2, and then the left person occupies that space over there, of which it gives you 48 again, because this is simply 4 factorial times 2 factorial over there. And then the last question, in how many different ways can they sit in a row if they're just males are just to sit together? So you're going to simply do the same thing as what we did over